Good day, everyone. So I'm here today with Jesse, our CTO, to discuss everything 1.5 and some other interesting topics that's happening internally with the TCD. So how are you today, Jesse?
I'm good, good. How are you?
I'm not too
Good.
bad. It's been a stressful day. It's been a very, very stressful day, but very productive at the same time. So I cannot complain. Now closing out towards the latter end of my day today. So yeah, great. Thank you. So Jesse, 1.5. Can you explain what 1.5 is? Very high level and obviously not too technical, please.
Yeah, absolutely. So 1.5, I'll take the opportunity to call it as it actually is. 1.5 is a term that's been given to all the work we've been doing towards the EVM upgrade that we've been working towards. So 1.5 is kind of grown to refer to fixes and improvements we're making to the smart contract. 1.5 has grown to refer to the RPC, which is most specifically kind of what we originally intended to do. Um, and 1.5 has grown to just refer to everything that we're doing to upgrade the EVM. Now, I think you know this, but to share kind of broader is like the smart contract itself has really no tight relationship with the 1.5 RPC changes. So, when we upgrade, we're also starting, we've been working now, and I'm really excited about the 2.0 work. That's, going to use the same smart contract, right? So, as part of the 1.5 RPC, we did set out one major goal with that was to have the block hashes be representative of what's inside the block, kind of as close to the Ethereum yellow paper as possible. Because before 1.5 and like the 1.0 release, when we started the EVM, the block hash was literally just a hash of the block number. So it doesn't matter what transactions happened in that block. You always knew. I could tell you what the block hash of a block in 2 months is going to be, right? I don't need to know what's going to be in the block. So that makes it really difficult for indexers and different tools to like follow when forks happen, micro forks, reorgs in the kind of EVM term. Um, and so when we built our indexer, we couldn't properly detect forks. So we needed to modify and change how we generate the block hash. And so part of that exercise, what we did was we kind of ran what they call a fuzzing operation. We compared our EVM with the Go Ethereum and the Silkworm and the Aragon clients, and we found some inconsistencies. And a lot of those inconsistencies were in the contract. So part of making the RPC behave the way we wanted it to involved finding issues in the contract. Now we've fixed those issues. We're working to deploy them and put them into production. And that then came part of this umbrella of 1.5, the contract, the RPC upgrade, the new Teloscan features that use the indexer, right? So the indexer needed 1.5. So now the indexer is kind of bundled in with 1.5 because it depended on 1.5. And then the features that we plan to add to Teloscan are reading from the indexer API. So that's all kind of just bottlenecked and back pressured like a champagne bottle behind 1.5 going live and everything kind of following suit. So that's at a high level what 1.5 is kind of a term that's loosely tagged on many different of our work streams.
That makes complete sense. And thank you for explaining that, Jesse. So the main thing, really, in very basic terms, the goal with 1.5 is to improve compatibility and stability, right? And you made some comments about RPCs and indexers. Maybe some of the community members don't understand the importance of a good working kind of indexer and also
Yeah.
an RPC. So could you kind of just explain to the listeners today what they both are
Mm-hmm.
and the importance of them as well, please, Jesse?
Yeah, definitely. So RPC is like the term that applies to the way that your apps, your wallets, any software you're writing that interacts with the chain can interact with the chain. So the RPC is kind of also the API to the EVM network itself. The RPC is a standard that comes from Ethereum. So there's all these different RPC methods, which are different types of calls you can make to the RPC. And those methods are all predefined, the behavior that is expected by all the tools, behavior that's expected by MetaMask and all the apps that people deploy on Telos EVM, and that they use the same code and same tools that they've used on Ethereum and other EVM networks. So that the RPC is a standard that we don't. I've said this before. We don't get to be creative, right? It's like we have to behave exactly like every other EVM if these tools are going to, be compatible and not have trouble because we're different. So we don't get to be different and creative at that layer of the RPC. But the unfortunate problem, though, is if anybody's listening that's done development on like an EVM on Ethereum, there's things that you'd expect to be able to do through the blockchain API, read certain types of data that the RPC just can't do. So to give you an example, if I want to go ask the blockchain who holds this token, it seems like a straightforward request. I want to say I want to know everybody that holds, the USDT token on Ethereum. You see it on Etherscan, you see it on block explorers, right? You'd expect it's just a standard call that you can make to the blockchain itself, but that's not the case. There's no way to kind of enumerate all of the holders of a token through the standard RPC interface. It's just not there. Like same with NFTs. Who holds this NFT? Or reverse it. What NFTs do I have? Here's my address. What NFTs do I own? Not, you can't. There's no way to do that directly through the RPC. So that's where the indexer comes along. So what the indexer does is the indexer reads all the data from the RPC. Every block, it reads the block, it reads all the transactions in the block, and it basically extracts and derives out data into its own database. So it's all an off-chain kind of system that reads all the blockchain data and stores it in a database and offers a different API, an alternative API to the RPC. So now, and that's where we can be creative, and that's where we can make like all of our lives easier for our wallet, for our Explorer, things like that. And all the developers building on Telos. We have this api.teloscan.io. That's the indexer API. And that data has easy methods to say, here's my address. What are my NFTs? Here's a token contract. Who holds it? How much do they have? What's the supply? What's the metadata about the token? We can have all this very like enriched data about blockchain data without, the blockchain providing it. We can enhance basically all that data. And then the indexer also stores all the raw data as well. So we built it such that it stores all the blocks, all the transactions, all the logs, all the things about the blockchain that you'd want to know. And then all the data that we derive and we extract out of the raw blockchain data is also available through those APIs. So we got NFTs, token holders, DeFi approvals, like everything that you might want to use a like API to read about, all the things that you see in the wallet and all the things you see in the Explorer, we can get out of the indexer. So it also performs better for certain operations. So when we first launched Telos and we built Teloscan, we pointed Teloscan at, we added, so I'll take a step back. When we built our EVM and our RPC, because it's bespoke and it's unique to Telos, we did add a few extra methods that we used for the Teloscan Explorer that made it so that we could actually show what you see on the Teloscan Explorer. So for today, if you go to teloscan.io, it's actually using the RPC, but it's using these extra special methods we added. And for that reason, it doesn't perform that well. So all the Teloscan traffic actually goes to the RPCs today, just like MetaMask and the apps. Everything that apps do that needs to use the RPC uses the RPC, but then Teloscan also uses the RPC today. But with the upgrade that I mentioned, Teloscan will use the indexer. So not only is the indexer giving us more and enriched data and allowing us to show you more things that you wouldn't see if it was purely the RPC that you were using, the indexer is also going to offload traffic away from the RPCs because Teloscan is now going to hit the indexer, and the indexer is using a traditional, it's a Postgres database. It's optimized and indexed very well so that the queries are fast. So with the upgrade that we'll do to Teloscan, it will offload the Explorer traffic from the RPCs, giving the RPCs, a little bit of breathing room, and then it will make the Explorer faster because the indexer is much faster, and it allows us to add like the holders page or other things to the Explorer that require that indexer data that's been enriched from the raw blockchain data.
Okay, perfect. And from a user point of view, Jesse, how would they, from an experience point of view, how would they see if, from their touching and feeling that's within the ecosystem, what would they kind of experience if the RPC was causing them issues?
So if the RPC was causing issues, they would experience potentially slowness. If the RPC was down, they would obviously not even see their balances loading in MetaMask or on the app. So traditionally in an app and like the front ends, the app may be using an RPC itself. Like if you go to a Dex and you load the page and you haven't logged in, then it doesn't have your MetaMask available to it. So it has its own RPC that it uses to read data. And then when you log in, it now has your MetaMask and it can use your MetaMask as well. So the MetaMask that you log in with does have its own RPC. And so the app might be using your MetaMask's RPC and it might be using the RPC that it has itself. Um, Oftentimes it's using the same one that we offer, the public one. But if either of those are having issues, you're going to see intermittent, like things not loading, things slow to load. If you send a transaction and it takes a long time for it to say it's confirmed, that just could mean that the RPC is slow. And it could also mean that the app is configured to check every 10 seconds, because on Ethereum it takes 12 seconds, right? Not all apps are designed to check as often as Telos. Telos blocks are half second, so you send a transaction, it might happen within a second, but maybe the app is checking every 10 seconds, and then if you miss the first 10-second cycle, it's going to wait another 10. So sometimes it's the app, sometimes it's the RPC. Generally, just intermittent, like inconsistent issues is where you're going to see it. And it can be based on any number of factors. The RPC may be working well, but if and it depends on the EVM, but if you're getting rate limited, if you're trying to load a really big page with a lot of prices, you know, it might have actually succeeded in making 15 or 20 calls to the RPC, but then you kind of got rate limited because the RPC is like, no, you can't do this many things at once. And then so the one thing you're waiting on doesn't work, or something on the screen doesn't show up, but other things do, and it feels inconsistent. So it just really can be intermittent and confusing for a user, because they just know, here's the screen, I expect it all to be painted with all the values that I normally see, and when something doesn't show up, it's difficult for us to know why without looking at it closely on their machine, right? And there's no way they're going to know what the cause is. So a lot of times RPC is kind of just where you point the finger, because it could be so many different things, but the RPC really is your gateway to the network. So if something's not working right, it's kind of going to be the scapegoat of where you point your your
So the
finger.
main takeaway on this then, Jesse, is at 1.5, not only the dApps are obviously going to see improvements from their point of view, but also users as well. They're probably going to experience quicker loading times and stuff like that with the 1.5 update, right? Which leads us quite nicely onto alternative RPCs and potential plans around an alternative RPC. I know we've had discussions as of yesterday regarding this, right? Because I know when I've been in other ecosystems and I've been rate limited as a user where I'm doing a lot of stuff, right? I just switch over RPCs, right, to a different provider. So can we talk about what we talked about at very high level and the potential things we're exploring? And why it's important to have more than one RPC provider. And also, I want you to delve in as well, Jesse, in regards to how our RPC is, what you explained to me yesterday,
Mm-hmm.
regarding that we direct from geographical locations and it's actually more than one RPC within an RPC kind of thing.
Yeah, absolutely. So, um, we have there's a number of publicly shared RPC like URLs or endpoints, right? But the main one that we prescribe, and the one that you get if you add Telos to MetaMask through like Teloscan or any of those places is going to be the mainnet.telos.net/EVM. That's the one RPC. So when everybody kind of thinks of Telos, and even yesterday when we first started talking, you said, why do we have just one RPC? And I said, well, technically we have a lot of RPCs, but everybody uses that one URL. And what happens when you hit that URL is it's called Anycast DNS is the technical term, but it basically, when you put something in your web browser like google.com, it has to turn that into an IP address, right? That's what DNS does. It turns a host name to an IP address. And then that IP address is actually how you talk to the machine, right? That's how your machine talks to the server that's in the internet. So the magic DNS says, okay, you want mainnet.telos.net and you are in the UK. So I'm going to give you the IP address of the load balancer we have in Amsterdam, whereas I'm in the US. So when I go and my computer says, what's the IP address for mainnet.telos.net, the Anycast DNS magic says, oh, you're going to get the one that's in Texas. And my traffic, so from my computer now, goes from my computer to Texas. And then in Texas, we have a load balancer. And in Amsterdam and in Hong Kong, we have a load balancer. And that load balancer, when it receives a request, it knows about all of the RPCs that we have running. And it's constantly doing health checks and making sure they're live and ready to serve traffic. So when it goes to Amsterdam, it does its best to send your request to the load balancer that's also located right there in Amsterdam in the same data center. If that one in Amsterdam is having issues or it has a lot of traffic and it's really busy, it may send your traffic from Amsterdam over to Texas. But the point being is that your computer didn't just go to Texas. Your computer went to Amsterdam, and Amsterdam did its best to keep your request from leaving your region, right? So the same for Hong Kong. If you're in Hong Kong, Singapore, Japan, China, anywhere in the Asia Pacific region, the DNS is going to send you to Hong Kong, and Hong Kong is going to keep your traffic in Hong Kong, and you're never going to have to deal with that global, ping latency that everybody knows it takes longer to get from here to Australia than from here to Texas, right? So that's when you hit mainnet.telos.net. That's what's happening is we're doing our best to shape your traffic and route your request and keep it local to you. And if there's issues, though, the load balancer is also designed to, be fault tolerant and send your traffic to the places that aren't having issues. So when you say, is there one RPC, there's actually, 6 or 7 behind that load balancer distributed all over the world. And that also helps, like if there's an attack or an abusive person, maybe even not malicious, but just they're trying to use a blockchain and they have a script that's out of control, their traffic's going to hit one of these, but the other regions are not impacted because they're kind of isolated there. So there's a lot more to it. And I think you saw the dashboard we have yesterday where we monitor it and everything, but that's at a high level what we do when you hit mainnet.telos.net. And then there's other URLs that we have shared publicly that allow people to go directly to those RPCs. The problem there is that if those RPCs have an issue, then as you said, you just
redirect. Yeah,
we can't redirect you because you're kind of hitting that one directly. So it's kind of a trade-off there. And when you talk about other networks, I mean, they'll have, they'll list theirs out, as like 1, 2, 3, 4, 5, 6, and then you're just left to pick which one. Sometimes they'll have the area that it's in, so they'll be like RPC US, RPC EU, right? So you look at the name of it, and maybe you can pick one that sounds like it's near you. But generally, like that's a lot of the times what you'll see is just a bunch of them, and you get to pick. So.
No, that's quite cool, though, I think, in all fairness, because on other chains that I've participated in the past, like if the RPC goes down, I'm like, there's an issue with this one, so I just flip it over to another one, right? But what our one does, it feels from a user point of view that it's one, where really, in reality, there's multiple RPCs behind the one from a customer-facing point of view. So it's actually pretty clever, right? And also, we've talked about alternative solutions as well, and exploring also on top of this, just for stability and stuff like that, um, and options within the ecosystem. But we were considering alternative RPC providers as well, and that's part of obviously some of our future plans as well, Jesse.
Yeah. So we, you know, even if we have the one running, things can happen. Obviously, um, that's having alternatives is always good, right? Diversification, having alternatives is a good thing. One situation that we have today that we are working to address is that the RPC, the one RPC that we just talked about, we don't really have a rate limit on it, so anybody can use it as much as they want. We've had to go in and like block a specific abusive IP that's just, I mean, we had an example. I think it was an arbitrage bot doing the same exact request 300 and something times per second. Like there was no different. Like you're going to get the same answer all 300 times if you keep asking, right? So we had to, rate limit or block some IPs. I think we rate limit them down pretty low when they're doing that type of stuff. So, but generally speaking, any new IP address, that arbitrage bot just has to switch IPs or switch their VPS host, and they get a new one, right? So we don't have any like global limit. So anybody like general users, they can hit that RPC and use it as much as they want, which is great. We want people to have access to our network. We want developers to feel that they just can start building right away. But as we grow, and we are growing and seeing this, more and more as we grow, that's not, sustainable, right? And if we 10x, we don't necessarily want to need to 10x our infrastructure, and you're gonna have 10x more abusers and 10x more these runaway scripts, even if they're not malicious. People make mistakes, so being able to put a rate limit on that public good, that free load balanced RPC that I described, that's reasonable. That you or I, when we're doing our day to day, you know, playing with the different games or trading or whatever we're doing on the network, we're not going to feel that rate limit. It'll be, generous enough. Just like with MetaMask on Ethereum, you're using an RPC that you don't pay for, but it's enough for you. But if you tried to do the same thing with like some script or an indexer that's doing a lot of requests, you'll get rate limited. So for us to be able to put that global rate limit in place and really kind of keep a cap on how much the free public load balancer gets used, that does two things. One, it prevents, that exponential growth from requiring exponential hardware deployment, but it also means that like, people that are using the public one, they shouldn't, be impacted by somebody that's running some rogue script, right? We call it the noisy neighbor problem. We want to reduce the noisy neighbor problem. We want that public one to be meant for users, and it should just work and not be, anything that people can abuse and cause problems for the whole, user base. So the problem is that we don't have an alternative, because there are valid use cases, right? There's use cases where we have partners that run indexers, we have apps that run subgraphs, we have all these different use cases where these people actually do need access to a higher rate limit than we would want to put in place for your normal user. Your normal user, 20 requests, 50 requests every 10 seconds is more than they need. But for an indexer, they need to be able to hit it a lot, and we don't have anywhere to send them. And that's really what, one of our goals has been for a while now. It's not been a top priority, but we've been trying to find a way to make that solved for people. And so an alternative that has a different approach towards it, that's not just giving away a free one that anybody could use without, creating a login or anything, is something that a developer type, persona needs. They need a place. And we've had partners ask us, some partners that are very sophisticated, mature partners come to us and say, okay, and where do I go to get paid RPC access? I want a dedicated RPC. I'm ready to spend the money today, and I just want access to an RPC that is going to give me as many requests per second as I want to use. And we don't have a place to send them. We tell them, well, the public one has no rate limit. You're welcome to use the public one and let us know if you have issues, but there's no rate limit. Just go for it. And then those partners are using the same RPCs that the users use, and then they're kind of competing for that attention from the RPCs. So what we've been working on, and there's a team that's planning to launch a worker proposal to kind of deploy a RPC as a service for Telos. There's partners out there that do it. We've spoken with them. They have pretty big price tags. They end up wanting a big upfront cost and a subsidy. They want us to subsidize the if they don't have enough people paying them monthly, they want us to subsidize that. So trying to find a kind of a middle ground that works well for us is what we've been working on. So the worker proposal is looking to be a good solution for that, at least to begin with. And it'll allow us to kind of put a good rate limit on the public one so that users get a good experience. And then the people that that's not good enough for, we will have an answer for them. We can say, you can go over here. This is a service you can sign up for. These services, most of them, if you look at the ones that are out there for other networks, they have a free tier. So you can sign in, you get an account, give up your email address, you get an API key, you use your API key every time you talk to the RPC, and then that API key is allowed to do 10 million requests per day or whatever the free tier is. But if you need more, you just pay $20 a month and you get access to you know double that or whatever the numbers are. And so that's what this intends to be. It's an alternative, and having diversity again is good. It'll be a different URL. It'll be something for developers to go try out and use. And as we grow, that's something we're really going to need more and more of, because we don't want the public one to become the one that every app, every indexer, every data analytics tool, all those people that really have more demand than the common user, they really need to be going to an alternative piece of infrastructure, basically. So looking forward to that. I don't know, maybe next week that'll actually be submitted as a worker proposal and people can vote on it. I been socializing a little bit with, you've heard about it. And so hopefully it gets put out there soon. And I know they've been, getting ready to actually build and deploy it. So hopefully it'll be pretty quick that we get that service online as an alternative.
Nice. So basically, for dApps, basically watch this space, because there'll be a paid for service, hopefully available shortly, based on obviously the success or the failure of the worker proposal. And from a community point of view, watch this space for the worker proposal that they should anticipate to see at some point within the next week or two, right, Jesse? So this is great infrastructure improvements for us, and we need these items as we look to grow as well, and obviously this is really important for the growth of the Telos ecosystem. One thing I wanted to ask you next about was, because obviously we run an indexer at the moment ourselves, right, for the community, and Gold Sky, one of our infrastructure partners, couldn't deploy their obviously indexer until 1.5 is complete. So now, from my understanding, correct me if I'm wrong, we're anticipating a deployment from Gold Sky to have an alternative indexer in the future as well. Is that correct, Jesse?
Yeah, and again, to go back to the 1.5 question, 1.5 we've had it deployed, but it hasn't been. Now that we've talked about this global load balancer, the one
Yeah.
RPC. So if you go to mainnet.telos.net, you're still hitting our 1.0 version, right? So, but of the alternative URLs that people do know of and people use in my MetaMask, I've got about 15 different Telos networks I can pick. The the 1.5 RPCs have been online for months, and people are using them. We advertise them as beta, and we make sure to disclose that. But yeah, because we have 1.5 online running stable enough for people to actually use it, Gold Sky is now able to begin their indexer deployment. So we're looking forward to that. And they also offer the subgraph services, so you can
Yeah.
deploy your subgraphs. Also, that's using 1.5. I didn't get into all the details of 1.5, but one of the other things besides our indexer is the subgraphs. There were certain formats of how we respond versus a traditional EVM that subgraphs didn't like. That is fixed on 1.5. So subgraphs, all of our partners running subgraphs are using these beta 1.5 endpoints that work for the subgraphs. And to call that out, if you go to wallet.telos.net and you look at your NFTs, you look at your approvals, you look at your token balances, all the stuff that's behind wallet.telos.net is actually using our indexer that we have running that is actually depending on 1.5. So And those features in wallet.telos.net have been there for many months, right? So 1.5, although it's not running behind the main RPC endpoint, is been powering wallet.telos.net applications, subgraphs, all these different things. It's, it's this very slow and like not linear release process, right? It's not just a switch. It's kind of a metamorphosis or an evolution type release. It's, showing up in different places at different times. And for me, the when we can consider the switch flipped is when we've actually cut over the mainnet load balancer, and we don't have to run 1.0 anymore internally on our infrastructure, because right now we kind of are maintaining and juggling both. JT, he's the one that handles and does the care and feeding of the RPCs.
No, absolutely. And I think that's a common misconception within the community, is that 1.5 is like this big red button and we just push it and it just goes and fires up everywhere, where it's obviously a phased approach, right? So I think talking about this openly and explaining this to the community is quite powerful from an education point of view, and also the importance of it as well. One other educational piece that I'd like to share with the community today is explain to the guys what a subgraph is and why it's important for the DApp developers within the ecosystem as well.
Yeah. So a subgraph is, so if we, I spoke about what the indexer was, right? And the indexer is taking the raw blockchain data that you can get, and it's extracting out information that is relevant. And that's information that's a standard, right? We pull out the token balances for ERC20 tokens. We don't need somebody to tell us about their smart contract to know how to do that. Same with NFTs. There's a standard 721, 1155. These are things that we know that we can extract and put into our database and give you an API for. But if you look at maybe a Uniswap, although that's become kind of a standard, Uniswap v2 and different applications. But if you look at people that are really building unique things that are custom, there's no way that we would know how to extract the data they need into our database, and we wouldn't know what APIs to create to read that data. So the place that the subgraphs come in is it allows a developer that's got a more unique use case than just what's the holders list of my ERC20 token, but they've got unique data. They know their smart contract. They know how to extract the data from their smart contract and put it into a database, and then what the API is that they want for their front end. So they want their front end, when you log into their app, to show, I don't know, but it's maybe an escrow thing or a lending protocol or something like that.
User data, right?
Yeah,
You,
profile or
yeah,
whatever it is that you want to show about a particular user on the screen. You would need to have read the data out of the raw blockchain data and put it into some database. And so users could write their own indexers, but subgraphs make it easy. You define a subgraph, you just define when this happens on the blockchain, store this entity in the database, and then the API for that entity is how you read that entity. So, like you said, user data, lending protocols, perpetuals, like potential liquidations, all the different data that's like not just your standard stuff that we would be capturing. They can write their own code. They upload it to the subgraph, to the graph node, and then that graph node is just going to be extracting that data and maintaining the data for them. And then their front end just points to that API, and they basically, it's like a custom indexer, right? It's like a custom scripted based indexer that lets developers, without us needing to know about it, or even if somebody's running a subgraph like Gold Sky doesn't need to talk to the developer and learn how their contract works. The developer just uploads the subgraph, and then they can put in their front end the data that they want to see without ever having to explain to anybody else, well, you look at this part of this transaction and you grab this value and store it like that, and none of that stuff. So that the developer can just write some code that explains how to store their data and extract it, and nobody needs to be in the middle of that process for them. So the subgraphs they're very powerful. The graph has been incredibly successful on all the EVMs and even non-EVM networks. And there's actually we probably haven't even talked about it, but one of the validators that we have on Telos, um, the Nation validator, they are also now part of the Graph ecosystem.
Wow.
They,
Know
yeah,
that.
they've been working with the Graph for a while. When I was in Toronto, I spent quite a bit of time talking to their CEO about what they're doing there. The company is called Pinax. That's their company for the kind of Graph type services. And they are really excited. They've already deployed it for Telos Native. So the new Graph is called Substreams. It's through the Graph, but it's a new kind of approach that's, you know, an improved version of the old subgraphs. It's called Substreams, and they have it now for Antelope. So Telos Native, they've got the substreams up for Telos Native that you can use to write your own substreams, which are similar to subgraphs. It's just kind of the new version, and we're looking forward to working with them as well on the EVM. Once 1.5 stable, they're ready to go, and they'll deploy the substreams as well. So that's kind of like the new iteration from the graph is the substreams. And the graph also, when they first launched, it was kind of centralized. They would host these graph nodes and they would have people upload subgraphs to them and their infrastructure. They've evolved to a decentralized model. So now, like today, the graph and all of the things they have going on is focused on being decentralized. So different entities can provide these graph nodes for the developers to upload their subgraphs and get that kind of custom indexer experience. So that's some really exciting stuff as well, is just kind of working with those guys to get it deployed for the EVM. I think they're a bit faster, and it's just kind of the new prescribed way to do that type of thing is using these substreams. So
Absolutely. And the subgraph is so important because if we don't have the stability on the network, right, and subgraphs go down for whatever reason, right, people get locked out on the UIs and they can't interact with the dApps from a UI point of view as well. And I remember because obviously I was a dApp, not a dApp developer, but I was part of a team that was building on Telos EVM. And there was many times where you would have users saying, oh, I can't withdraw my liquidity, as an example, right, because the subgraph's down. So I understand fully from a DApp builder point of view and from a community member point of view the importance of the subgraph. And also to have these service providers come in and offer this as infrastructure with obviously the Substream offering coming and obviously the Gold Sky offering coming as well. It's important that we grow our infrastructure with the growth of our ecosystem and the amount of dApps that we've got deploying as well, right, though, Jesse?
yeah, I mean, if you look at it, we run the RPCs, we run our indexer. We have ran a subgraph before and let dApps upload to it just as a service, partially to support them because for whatever reason they weren't able to run their own, or so that we could observe. Like that was part of a learning exercise with figuring out why it might not be working on 1.0. We want to run it ourselves and observe. Get hands on to reproduce issues and fix them ourselves and keep it alive for those dApps. So, but it doesn't scale, right? We will continue to run a public RPC as Telos as we have. We'll continue to do our best to add extra services, but at a certain point, what you really need is people to come in that focus on that service as a third party infrastructure provider that
Specialists, right?
it offloads from our shoulders, right? And then we can focus on us doing what we do best that we want to focus on in our core competency, which is not running, 5, 6, 7 different services as a public good. It's, running a nice public RPC and building the EVM, building the side chains, iterating on, our infrastructure, our networks that we want to be deploying and maintaining. So, yeah, it's important, very important to get these third party infrastructure providers to distribute the workload of maintaining it and also just have options. Like you said, something's going on, hit the drop down, pick a different one. There's options.
Absolutely. And I think what people need to understand as well, it's actually quite time absorbing to actually find cost effective solutions because infrastructure providers can be really, really expensive, right, Jesse? So it's not like we can go, we know what infrastructure providers are missing currently within our ecosystem. Let's just do it because it isn't as easy as that, right, Jesse? Right. And because we need to have some fiscal responsibility around obviously the treasury and stuff like that, right?
They're all
So
looking. they're all they're all for-profit businesses, right? There's
Exactly.
not and so they want either to see a huge amount of demand for they
Mm.
want to see like significant profit opportunities from our development community to pay them to use their RPCs, or they want us to basically subsidize those costs, like I mentioned. And
Yeah.
there's a big upfront cost for them. Another key point there is our 2.0 release, which will have a number of things that it does. One is it brings more compatibility, but like RPC compatibility for the tools, right? But the other two very significant things, which are very related, is node operator ease of use for a person running a 2.0 node. It's just simpler. It's much more familiar because our 2.0 architecture will be basically the same experience as running a node on Ethereum or other networks. Our 1.5 is like multiple services, and you have to kind of turn this thing on, configure it properly, turn this other thing on that you have to configure to talk to the first thing. You got to wire up all these different. So it's our 1.5 and our 1.0 architecture are more complex for the node operators. So it's harder to even have those conversations with those third party providers because we're asking them not just to add support for us, but to have their DevOps team trained and incorporate our stack of multiple things into their kind of system. And their system is built for these other networks simple EVM
And that
nodes. And
adds costs, right, Jesse? That adds costs, right, because of the
it has cost
compatibility.
for us because it adds complexity and cost for
Yeah.
them. And with 2.0, we expect it to perform much better in a lot of these examples. So they won't need to run as many. Like, and even for us, when we launch 2.0, we should be able to either reduce some of our hardware that we have to pay for each month, or just have more RPCs, right? Because we now we have instead of having one RPC spanning on two servers, we've got four RPCs spanning on two servers, right? Like something like that can happen. Or we recover the cost of one of those servers and we have two RPCs now instead of one, and they can perform, maybe better than one of the old ones. So with 2.0, we can actually maybe rekindle some of those conversations, or at least hope that the opportunity is easier to make happen because the infrastructure is easier and more performant, easier to run and more performant.
Absolutely. This one's going to make you laugh, this question, Jesse, because I know I've asked this a few times. So I'm going to ask it here today. In terms of our block explorer, and I'd imagine you've been asked this a number of times, and I'm going to ask it again. Um, why doesn't it look like Etherscan? And what plans have we got to kind of make it look a little bit more industry standard?
So when we first launched the EVM,
Mm,
we attempted to use Block Scout, which is like an open source explorer, which it does look. I don't know if it looks just like Etherscan, but it's not an ugly explorer and it works well. A lot of networks use it, but because again our RPC is and especially when we first launched, not 100% consistent and compatible with other EVMs, it just wouldn't run properly. And it's written in a piece of software that's very hard to manage or modify. So we realized, well, that's the only open source option. We're going to build our own. So we built Teloscan, and as part of building that, at the time, the people involved, we had other people involved that kind of led some of the decisions there. In fact, some of the design decisions were basically, let's try to be different. To be
mm,
honest, it was kind of like, let's be different. Let's differentiate ourselves. We can do better. We can be different. Well, that led to intentional goals to not look like Etherscan, right? So it almost ensured that we didn't look like Etherscan because that was kind of the direction that was taken with the design. And I'm an engineer. I'm not a designer. So, and I have used the Teloscan. I know my way around it. I know my way around Etherscan very well too. So it has all the data and functionality that I need, and everything that we've kind of pushed for and focused on has been get the functionality, get the read and write interfaces. We're working on proxies right now, so you can read and write through a proxy. We're working on all the different holder pages and all the different things that at an engineering level that you go to a block explorer, you want to be able to see and find. And anybody that's used it enough and has the patience to learn a new kind of roadmap to find the things they want, they've been able to find those features too. But for the general users, they don't see something that's familiar like Etherscan, and they're lost. They don't even consider that they have to find the thing, that it's still going to be there, but it's in a different place through a different screen or a different path to get there. Um, so that's been a problem. And you're right. I've heard you have brought it up, and I said, "Well, what's bad about it?" And it's literally you and many people have said, "Well, it doesn't look like Etherscan. I don't know my way around it." Right.
Yeah.
And then you mentioned, the holders page, and I show you that we haven't released it to mainnet yet, but it's there.
Yeah.
Um, and that we've built it, and it comes with that 1.5 release. And the performance, it's slow, but again, as I mentioned earlier, telescan on mainnet is slow because it's hitting the RPC and it's using these methods that weren't really purpose built for that.
Of course.
And with the indexer and 1.5, it's much faster. And I've shared that link in Telegram with anybody who asks. I'll give them the beta deploy preview that we have, which is live, and you can see it performs better. Testnet actually, as of I think yesterday now, is running that as well. So we're getting close to releasing those improvements. But the look and feel, as you've highlighted, is the number one kind of gripe that people have, which is great to me. I mean, people think that it looks that way because it's how we want it to look, and maybe that's how it got there in the early days. But
It's not
it's
a
just
priority, right? It was we got all
just
the
the circumstance.
functionality that we need. There was some upgrades what you guys are currently pushing, right?
Yeah. So
And
getting it
you
to look.
felt that is a priority. No, so you got the functionality right, but based on some of the designs that I'm seeing coming in today, they look great, though, Jesse. You must say, right?
Yeah, I barely had a chance to glance at him before we got on. I got on my last call, but yeah, like so having heard it come from you, obviously you came in and you said, you said there's problems with Telescan. I said let's drive in,
Mm,
let's drill down and see what they are. And first thing, it doesn't look like Etherscan. I'm like, well, that's great. I'm not attached to the design,
of
and
course.
that's like one of the easiest things to change. Is take everything you have, move it around. Oh, that's easy. Like that's not like building the read write interface that uses a proxy diamond, all these complex pieces of functionality. Those are hard things to add. The holders page, we had to build a whole indexer to store the data to show you the top holders of a token, right? These are hard things to do. You tell me I just don't like the look and feel and I want it to be laid out more like Etherscan. That sure, that's easy. Let's do it. Let's get a design, as you said, and start the process of like making it more familiar. Let's look at and then when we had that conversation, we looked at Avalanche. They had Snow Trace, which was Etherscan, and they've since moved on to their own, which looks just like Etherscan, right? It's got their style and their look and feel, but so it's not it's what people want, it's what people expect.
Mm.
So it's definitely something that we're gonna look to do, right? We're working on it, and I think once we have that look and feel improvement, we're gonna have a lot of people very happy, and hopefully it coincides pretty closely with all these new features being released. And it'll really feel like a 2.0 version of Telescan.
I'm really excited for that because I miss a block explorer I'm used to go kind of moving around, right? So I really am truly excited for that upgrade, and I'm looking forward to that. One kind of interesting topic that I want to kind of finish up on is obviously the fun story about, well, maybe not fun for maybe you guys at the TCD, but for maybe some of our listeners around the most recent DDoS attacks and what the individual tried to suggest. So I thought that'd be quite a funny story for you guys, for you to share to the listeners today, Jesse, around the interaction with this person and obviously what you witnessed and how you counteracted that as well.
Yeah, so this is the first time that we've had this type of conversation for the RPC, but it's not the first time we've had this type of conversation with a anonymous account popping up in Telegram. Basically, they present themselves as security researchers or security professionals, and they found a vulnerability in your code, which makes every engineer go, "Oh, right." And that's where bug bounties come in. People expect a bug bounty if they find a bug in software, right? um, but then what they actually proceed to try to explain as a bug is them doing like a DDoS, like a full network based attack, nothing to do with the code. It's happened like 4 or 5 times with Telos.net. They tell me Telos.net, I found a bug in it. I'm like, oh, what's the bug? Well, look, I can take the page offline. I'm like, well, okay. So we don't even host Telos.net. It's through like, a Webflow kind of CMS type system, and you're DDoSing their infrastructure. That's great, but you don't need to talk to me. You should probably go talk to this infrastructure, CMS hosted provider, and let them know that you know how to DDoS their infrastructure. And you probably, I'm snarky at times. I said you should probably give them your information and your identity so they could pay you the bug bounty. Tell them you're attacking their infrastructure, and then give them your name and personal information so they can pay you, because what you're doing is illegal, and you're not going to give up your identity. You're just trying to kind of extort a bug bounty out of us for being able to take down the infrastructure. And there's ways to mitigate this. You can use Cloudflare. They're like one of the number one people that kind of protect against this. And so, but yes, earlier this week was the first time we had somebody come to us as a security professional and say they found a vulnerability, and then give us a bunch of mumbo jumbo and tell us that they're able to, take down and degrade. The words they used were like nonsensical, but basically they were DDoSing the RPC, the mainnet load balancer. We detected like like hundreds of IPs. We extracted those IPs, blocked them in the firewall, and then hundreds more came back. Which there's a tool you can use to search IP addresses and find out who the providers are in bulk. We pasted this list of IP addresses in that tool, and we found they were coming from providers from all over the world, all different providers. So it's not like one person with some infrastructure in one data center. It was somebody who had access to very decentralized, distributed providers and machines, which is what you would refer to as a botnet. So they had access to machines that are probably compromised, like literally like people's Ring doorbells and whatever devices this, and this probably is somebody who went on the dark web, got access to a botnet. You can rent them on the dark web and use them. And he went on and, decided he would try to attack us. JT looked deep. He had tried to attack us about an hour earlier and didn't have enough, gas on the fire. So he came back with more. And then he messaged somebody from our team saying, hey, I'd like to report this. And I told that person, I said, they're attacking us. Just ignore them. And what happened actually was I said, they asked for money yet? It's like, no. I was like, they will. Well, then they did. Oh, is there any way I can get, is there a bug bounty for this vulnerability? It's like, no, you're attacking us, and we're going to mitigate it. And so, yeah, to your question, what have we done? We did put in a rate limit, actually. There's a 200 requests every 10 seconds rate limit that we have on the global load balancer at this point, just because, and that's, again, not nobody's going to feel that as a user, but we even made sure that like the indexers and the partners weren't using that many requests. But for him, it will prevent that. And then we also are now beginning the process, which we had planned, we wanted to, but migrating to a Cloudflare based kind of edge proxy, so that traffic always goes through Cloudflare where they can mitigate it. Also, we've discovered, I don't think you were even aware, but the place that hosts our infrastructure, you can pay for the DDoS protection at their firewall. So there's a lot of different ways to do that mitigation, and it's entertaining to see. I almost, at this point, now that we've put in more mitigations, wish, if he wants to be paid, I'd probably like give him a little bit just to turn it on again, just to make sure that, I want to test this stuff, right? Like make sure that it still would mitigate. But yeah, it was an interesting thing to see. We had I think an extra 10,000 IP addresses in our logs for the day than we have on a normal day. So it was definitely a DDoS attack, and interesting to watch happen. And again is a very reaffirming thing that having a third party RPC provider, having other alternatives, is important, right? In that example, people that were maybe using this other RPC service wouldn't have been affected. So it's definitely a learning lesson, and we were poised to handle it, and we handled it pretty well. And if it were to happen again, we've added a handful of further mitigations. So it's the first time in 2 years. It was kind of fun.
I thought it was just a fun story to kind of share to the community about some insight behind the scenes of the TCD, what you guys deal with. It isn't just obviously development and maintenance and developer debt. Sometimes there's this reactive stuff that you guys have got to move towards as well. But
Oh yeah,
Jesse,
we have
uh,
alerts when that started. Our
yeah,
like things started blowing up. We got alerts in multiple directions, emails coming in. Everything's what's going on? And then we go look. We have the dashboard that tells us what's going on, and
yeah,
very quickly we identified what was going on, and then kind of war room mode, and
yeah.
just deal with it. And it went away pretty quickly, but it wasn't a normal day to day thing. It was kind of a nice spice it up type experience.
Absolutely, absolutely. Well, Jesse, I want to thank you for your time today. I thoroughly enjoyed our conversation. So hopefully this is the first of many that we can record and share our conversations with the community. And also to the community, thank you very much for listening in today to our discussion. And I hope you learned a lot today and took a lot away from this conversation. And if you've got any comments or questions, so when me and Jesse get in the room again together for another conversation, then we might be able to assist with maybe some of the questions that you guys might have at the community. So thank you for tuning in. And until next time, we'll see you again.